Okay, let's move on and do exercise 5.46 on page 233 of the textbook. This is a problem where a consumer advocate has claimed that 80% of cable TV subscribers are not satisfied with their service. And we are asked to look at some statistics, some survey data, and see if this makes sense or not. So first of all, the book says, let's assume we take a sample of 5 subscribers, and assuming independence, that is, the answer that the second person gives is not influenced by the first person, which you have to be a little bit careful in how you design the sampling process to make sure that doesn't happen. But assuming that, what is the probability that 4 subscribers or fewer are dissatisfied? So what we can do, because this is a I'm sorry, 4 or more. Did I say 4 or fewer? 4 or more subscribers. I should type that into my little thing here. 4 subscribers or more are dissatisfied. Now, what we can do here is, because we have the independence thing going, we can do this as a binomial distribution. So, the first question then is, what is our random variable going to be? X. That's the name of it. What does it mean? Well, it's the, in this case, the number of unhappy subscribers. So we are in effect saying that success is equal to unhappy. So if I survey a person and ask them, are you happy or unhappy? They say unhappy. I say success. Doesn't make much sense, but that's why we have to do it this way, because the percentage we were given, the 80%, is expressed in terms of unsatisfied. Now, if we want to do it the other way around, if it makes you feel better, we could do it with 20% and say that success is satisfied. But then we have to change our thinking around. Let's just stay with success being unhappy. And if you're a consumer advocate with an axe to grind, maybe that's what you mean by success. So X, what values can X take on? Well, it can take on 0. No one is dissatisfied. 1 person is dissatisfied. 2, 3, 4, or 5 people are dissatisfied. So those are the values of X. Now, because it's binomial, and because this is Sunday, I'm not going to go out and draw a tree for this situation, a outcome tree. I'm going to use the binomial distribution. I think in Minnesota it's illegal to use factorials on Sunday. I'm not sure. But at any rate, I'll type binom distribution. I just love it the way it gives you the word. I don't have to remember exactly how to spell binomial distribution. The number S is the X value I'm analyzing, which is 0. The number of trials is 5, and the probability is 80%. Now I have to put my dollar signs in here, because you know I'm going to just drag this formula down to the other 5 cells. So I don't want cell F6 to change as I drag down, and I don't want B4 to change as I drag it down. Oh, I've got to put the cumulative in. Let's say 0 for cumulative. I don't want cumulative. I want just the individual probabilities. And that tells me that the probability of no one being dissatisfied is 0.00032, not very likely. So I can grab hold and drag, and this tells me that I get those probabilities. Now, the question is, let's put that so we can read it a little easier. Let's give it another decimal point. Okay. The question is, what is the probability that 4 or more subscribers are going to be dissatisfied? Well, 4 or 5 means add those 2 together. Remember, they're independent. So it equals that one plus that one, or 74%. So if 80% of the people are dissatisfied, then the chances of taking a survey of 5 and getting 4 or 5 people who are dissatisfied is 74%. Not very high at all. All right, it says, now B says, all right, that's interesting, but let's do a bigger survey. Let's do a 25-person survey. Well, X now can take on values. I got to move this up, don't I? X can now take on values that range from 0 to 1. Now, I'm not going to type down to 25, but here's a neat thing Excel will do for you. If I grab hold of 2 of these, I've highlighted 2 of these by holding down the Shift key and selecting both of them. I can drag down, this is going to go off your screen, but I'll show you. If I go down to 25 to 45, oh, that was one too many. I wanted to go to 44. See what Excel has done? It has incremented it each time. So I now have a list of numbers that goes all the way down to 25, just what we want. Okay, that's X. Now, the other neat thing is because I use my dollar signs, I can take this probability formula and just bring it right down here. Right there. What this formula now says is calculate the binomial distribution based on A19, this fellow right here, F6 and B4, the ones that are up here. So I'm still using these numbers up here. Now, because of that, if I still want to use this cell, I'm going to have to change it from 5 to 25. My 80% stays the same. But now, when I drag this down, I'll go all the way to 25. You can see that in the early going from 0 up until 13, it doesn't even come on the radar screen here. So with an 80% dissatisfaction rating, or probability, there aren't many people who are really very satisfied with this service. So there's the distribution. The peak of the curve is where around 20. The mean value, I guess we would guess, of the population who are dissatisfied is around 20. In fact, what's NP? 25 times 0.8, that's 20 exactly. So that's what we would expect. Okay, now the book asks us, first of all, with probability that 15 or fewer subscribers in the sample are not satisfied. So 15 and fewer would be anywhere from 0 to 15. So that answer is easy to get. We just say sum of 15 down to 0. You go to 0 to 15, doesn't matter. You can see that Excel is called a B19 through B34, not the other way around. It knows what it means. So the probability that 15 or fewer people in the sample of 25 are dissatisfied is 17%, 1.7% rather. That means that there's a 98.3% probability that more than 15 are dissatisfied. Number 2, probability that more than 20 subscribers are not satisfied. So that's easy. That's the sum from more than 20. I'll get it up here where we can see it. Okay, more than 20 would be not 20. Does it say more than 20? More than 20. So we don't want to count 20. More than starts with 21 through 25. And that number comes out at 42%. The probability is that 20% or more of the subscribers will be dissatisfied. Number 3, the probability that between 20 and 24, yes, that between 20 inclusive, so we'll include 20 and 24, equals the sum of 20 through 24. That number comes into 61%. And the probability that exactly 24 are not satisfied, well, that's just one value, so that's be this one right here, 2.4%. So if you were the consumer advocate, you'd say, hey, folks, people are not satisfied. Look at all these horrible percentages. 61% of probability that 20 to 25% of these people are dissatisfied. That's terrible. Well, wait a minute. Now let's go out and do a real survey. And just suppose that when we did that, we find the actual number who are dissatisfied is 15. Now, what's the probability of getting 15 people dissatisfied? Well, there's a 1.2% chance that exactly 15. But the better question is, what's the probability that 15 or fewer would be dissatisfied? So let's calculate that one. Sum of 15, and you know it's going to be just about the same because all these other numbers are 0. It gives us 1.7% right there. Now, here's the catch. That means that if you want to believe this, then you have to believe that this random sample, which only has a 1.7% chance of ever occurring, actually occurred in this case. Not very likely that the consumer advocate is correct. Okay, I'm running out of time. On to part C.